Dear civil engineers, in this lecture we're just going to show that how we can design isolated footing or single footing by using CSI SAFE 2020. Okay, so to do that we have to use this software perfectly because this is a new version. That's why I'm creating this tutorial series. And also after opening that model, I'll just go here, new model. You all know that what we have to do actually. So from here I can select that option. So from here I'll just use US customary, then region for default materials. So I will use United States, and here everything will be okay. And design, you can change your design code. So I am using 31819. Then okay, so after that I'll take grid only option, okay. And for single footing it's okay if I take that grid only option. And from here model datum and the studio height, okay, I'll not take it seriously. So just simply take grid only, then click OK. So after clicking OK, just wait for some time. Now we'll start modeling here. So what we'll do actually, first of all we'll define our materials property. I'll just go materials property, and here from here actually you know how to change that. Okay, so I'll just click here, add new materials property, then from here United States, and you can change select your region, then materials type. I'll select concrete first, then customary, here it's customary, and they have many available value here. Okay, they have available. So if I click here for user default, then I'll click here, and I'll take a 3003 KSI f prime c equal to 3 KSI. Okay, and from here what will be the unit weight? 150. It's okay. And here modulus of elasticity, how we'll take our modulus of elasticity 57000 into 3000 root 3000. So here to the power 0.5. So to the power 0.5 and root are same, then enter. So here our modulus of elasticity, then Poisson's ratio 0.2. It's okay. Now I'll just go here, design properties data. So here I'll just change it. I'll change it for grade 3, and I'll change it 3000 pound. Okay, then okay. So this is the way to define our concrete properties. Then again as new materials, then similarly from here select river, and if you want to use user manual, or you can use the default formats. If you use user manual, you have to go the same way previously have done. So if I just click here, then they have 3 grade, 40 grade, 60 grade, and 75 grade. So if I use 60 grade, then if I click here, just see here 60 grade, and also these 60 grade are here available. Okay, STM A615 grade 60. So this is also available. So I'll not take that on. I'll use in this portion, I mean this property I will use. So okay, after that I'll go here. So for section properties, so to draw our slab section, to create our soil foundation, I need that option, slab section. So from here I will delete that one, and I'll add new properties from here, the slab. So what will take, I'll do footing, FWTING footing, and from here I'll select our materials properties. Okay, slab materials, f prime c equal to 3 KSI, and here shell thin, it's okay. So after that I'll click here slab. So from here I'll select footing, that option footing, and what is the thickness of footing? I'll take 12 inch. From here I'll take 12 inch, and here I'll just give 12 inch. So it's okay. After that I'll click okay. Again I'll click here. I'll take a copy of that materials, add a copy of materials, and here is stiff. that will be column stiff. So what will be the column stiff? Actually, column and here column stiff f prime c 3 ksi, it's done. And from here I'll select stiff, clear, then it's okay, and okay again, then okay. So we have defined our footing and column section also. Now we'll go for creating that. So two way we can do that. We can take point for that, okay. Otherwise we can draw the rectangular slab with respect to grid system. So I prefer to create that using point. So I'll just go ahead, draw joint object, and from joint object, okay, from joint object I'll take any point as a center of our isolated foundation. So what I'll do, I'll just go to for x direction, I'll take 3 feet or 4 feet, okay. So if I take 4 feet, 4 means 4 times 12, I have to take that value in inch, so that will be 48, and in y I'll take 3, 36. So if I just click here, so okay, to see that actually I have to click here for plan. We have to click on plan view, and is it available on elevation view, then it will not be available. So I'll click here for plan view, and again I'll take point here, draw joint object, and I'll just go minus x 48, and in y 36, enter. If I just click here and again click here plan view, now see it's available. Actually it's take time to refresh, and again I'll go draw joint object, and here 48, then minus 36, and then just click here and take that the minus value, minus 48. So to create that option, now go to click here for plan. Now see here we have taken 4 points, okay, we have taken 4 points. Now what we'll do, actually I'll just create slab on it. So I'll click here, so I'll draw footing, so 12-inch footing, and from that point I'll just move it from that point to that point. Just see here we have created our footing. So after that I'll go for here, I'll go for that option, or I'll go for that option, draw quick wall or floor, or here. So I'll take that option, okay. Draw quick draw area around the point, so I'll click here, and from here I'll just click here for column stiff. And what will be the dimension of column? So I'll consider our column will be 12-inch into 12-inch. It's depend on your work. So I'll just click here. Just see here we have created our column stiff also. Now if I just go in 3D view, okay, so here this is your view, and if we go for extrude view, just see here the section we have created are available here, okay. Now when it's done, we have to go for the next step. So what we'll do for our next step, now we'll assign load on it, and before that we'll go 3D. I'll select just stop extrude view, and here I'll select that on that slab and footing area. Now we'll go here for the assign, and from here shell, okay. Actually from shell, or they have another option. So from that option shell we'll assign our area spring, okay. So before assign area spring, in area spring we have to define area spring. So I'll close, and here I'll just go, then spring property, then area spring. Now add new properties, and here area spring. So here we can tell that this is soil subgrade modulus. Okay, now what will be the subgrade modulus for keep per inch square? And that will be compression only, so we'll calculate that value. I'll open an Excel file. This Excel file are available in our website, and link are given in description. So if you go to our website from the given link, then you will find a free section, and from there you will be able to download. So what we have to do, actually you have to provide here allowable bearing pressure or bearing capacity of soil. So I'm considering that bearing pressure are 2 TSF. I'm just considering that, and factor of safety, I'm considering our factor of safety are 2.5. and here what is the allowable settlement in the foundation? 25. So I'm just considering that one. This value can be different for your case. So here we need keep per inch cube, that value. So here is the value 0.077. I'll just copy that one. I'll take that value as a I'll copy this value as a number. I'll copy that value, and after that I'll go to software, and here I'll just paste it. Now I'll go OK, then OK, done. After selecting that footing, I'll just go here, assign, then shell, then area spring, here area spring, and I'll select that on and apply. Clear, then close. So we have assigned our area spring over the all over the portion. So after that we have to provide load on our model. So I'll select that point. After that I will go assign, and here we have to provide joint, we can provide here as a joint load, right? So I'll use that all of our load as a joint load. I'll go here for force, and what are the value here actually? So I'll consider we have two loads, one is dead load and another is live load. So for dead load, suppose for dead load I'll take that value global z. What is the direction of global z actually? So here our z, the upward direction are global z. What I'll do actually, I'll just go down here. I'll provide the value as a minus value to provide that value in opposite direction. So I'm considering this is 35 kip minus 35 kip, and moment in x and y direction I'm just considering this is 3 and this is 5. I'm considering that moment are available for that dead load. And here the most important thing, punching shear, the size of load for punching shear. So this will be the same of our column strip size or column size. So that will be 12 and also 12, as we have taken that value as a 12. Our column size was 12. So it's done. After that I'll click apply. Right, again I'll click here pre-select to select that point. Again I'll take the live load, and here I'll consider our live load will be 60. Suppose our mmx will be minus 10 and our my will be 9, suppose, and this value are okay. And here replace existing load, then apply, then okay. So load already have applied it on our model, so everything is okay. So when everything is okay, we'll go for analysis. I'll just click here. It's done. Oh, before that I'll go here load combination, and I'll delete both combo. I'll add combo 1, and for dead load 1 scale, and for live load 1. Okay, 100% dead load plus 100% live load for service load. Then I'll go for okay. And here I'll consider, or I mean I'll take our settlement. So for that, so here deformation from combo 1, and just simply click here. Okay, so here what is the displacement? We have to take our displacement from here. So just see our available settlement are 0.9, so on 1 inch, but here this is very low. So if we see here, this is 0.2. So we have opportunity to decrease our slab size and thickness also. But before that, I'll go for our soil pressure. So I'll click here, display soil pressure. From here I'll take combo 1, and everything will be okay. And I'll just click here, apply. Now we'll take, so what is the value here? We're seeing that our soil pressure are maximum soil pressure are 2250. So if we just go here, our allowable value is 4408. So what we'll do, actually will even again will decrease our size, slab size, to design this foundation as an economical foundation. So I'll just close. Okay, I'll close, and we'll go for our punching shear. Take on display, then here sorry, I'll just click here for different shape. I'll go display, and here option are not available here. So this concrete, then click here, design or check. So again I'll click here, design or check, then display. Yes, now it's available. Show punching shear design. I'll click here. Just see this punching shear value are also very less, 0.058. This is really very less. So what I'll do, actually again I'll go for it. So what we'll do, I'll unlock our model, then I'll go define, then section properties, sorry, the slab section, and here for column stiffer footing I'll consider 8-inch footing, 8-inch footing. Okay, and for column stiff also it should be 8-inch column stiff. Then okay, after that, if I just go extrude view, here in our extrude view, so when it's done, again I'll go here, run analysis, and we'll see what happened. So here I'll go for our deform shape for combo 1, then apply, option wire windows, done. So here what is the maximum? 0.019 is the maximum for combo 1 settlement. And if we go for our next value, so for soil pressure combo 1, then apply. So this again same 220069. It's done. Now what we have to do, actually we can decrease our slab size. So simply by after clicking here, just go to plan view, and take new point to resize our footing. So what I'll do, actually I will go to an X direction for 12 inch and Y direction for 12 inch, I mean minus 12 inch. For that point I'll click here, and if I just click here, just see a new point are available here. And again I'll go draw joint object. In X direction I'll go 12 and Y direction I'll go 12, then enter, then I'll click here for point here, and in X direction minus for that point here, and for that point also Y will be minus, enter, and for that point. And if I just click here extrude view, just see we have found our new view or new point. So I'll click here reshape object, and I'll click here, and from here I'll just go here, I'll just go, sorry, Ctrl Z, I'll go from that point to here, then I'll click here again, and from that point to here I'll again click, I'll go here again, I'll click, and from that point to here, same here, then escape, again run analysis and design, checking our model. So here our minimum displacement that are showing here for dead dot only. So I'll go for minimum, so for combo apply. So here the maximum value now 0.039. so also we are able to optimize our section. And for soil pressure combo 1, then apply, and now it's over now. Actually now it's 4398. that means we have to if I just click here, it's 37, in that point 40, 41, and here 43, and what is the allowable 4408. that means now it's almost optimized. So when it's done, if we click here show value also and show lines, so it's done. Now we'll go for design display, design punching, so it's 0.114. now it's okay. Actually for your time you can optimize that many times. Now I'll go for design. So from here I'll click here start design or check. So after that, when it's done, when our design is done, okay, after that we'll go here, I mean we'll click here display, show slab design. Here there are options, show slab design. I'll click here. So oh, before that we have to draw a stiff on it. So I'll click here, and I'll unlock it again, and I'll go here draw design strip, draw design strip. So from what we can do that, from that point to that point we can take a strip, and from that point to that point we can take another strip, like that. So it's done actually for this time. In our next lecture we'll go for more details. So again I will run our model. Okay, our design and run are okay, and from here also we can take our for combo 1 axial force. If we go for axial force, and okay, sorry, here, then I'll I'll click here, and now steep base force. For steep base force, we have to go here for that option actually for our slab. Okay, so for moment, just see here our moment diagram for shear layer A. This is for torsion. There are little bit torsion, and for axial force. So here for axial force. So what I'll do now, I'll go for design or display, then show slab design. I'll move it here. So first of all, I'll go for finite element based method, impose minimum reinforcement, and for top river, direction on top river apply. Just see here we record river, but in that side we record more river than that side. Okay, so if I just go here for top, and for direction 2, if we go for top river, just see in that direction also we record in that side more or less record than that side. So for top direction 1, if I just go typical uniform reinforcing specified below. So if we use number 5 bar with a spacing 12 inch and 12 inch, then apply. Just see if we use number 5 bar in top with 12 inch spacing, then there are no reinforcement required. So if I just go for 15 inch into 15 inch, then apply, also it's okay for our top 1. And if we go for top 2, then also okay. So you can use any spacing in top, no problem. After that, I'll go for bottom direction 1. Also not required much more reinforcement. And for bottom 2 direction, this is also same. So if I just go here, then apply for bottom reinforcement. Here we are seeing that 0.017, and in that side 0.001 reinforcement are required. So if we just go for strip base for layer, we have done a mistake maybe for defining our layer. If I just go here, okay, we'll check that later. So for top and bottom, or you can leave it. So if you use number 5 bar everywhere with 15 inch spacing, so it's okay. But we'll surely use 12 inch into 12 inch. Actually, you term when you will use your value, then you will use your value perfectly without any problem. So thank you very much. That was our today's lecture. And also, if you just go to detailing just by clicking here, or before detailing, you can go bar bending schedule for here the curtailment rule, and also detailing here for slab mat and footing. For slab mat and footing, also you can use that option. Here many options are available. In another lecture, we'll give you a detailed lecture on it. So when it's done, if we just click here, so here our layout plan, then if I just go here, layer A, top river. So for top river, it's showing here the value, and for bottom river, the 2 river requirement, here on and here on in direction 1 and direction 2. For layer 2, so at the top, at the bottom, view, footing object, then plan, then top river plan. Just see here number 4 bar at the rate of 16 inch. That means 16 inch away we can provide river, but surely we will not provide much more less reinforcement. So here the wall bottom river, and if you go for preview, just see it's showing the river here, but this is very less actually, because we have provided a section we have provided a section, reinforcement section that are, we have provided a load on our structure that are very low, but we have provided our footing size and column size are very high. That's why it's showing us that problem. It's showing us a less reinforcement. So here are the requirement of our bottom and top lever actually. So it's done. And actually in our next lecture also we'll go for our another model and we'll design for it. So thank you very much. Stay connected till next video.